So in math, we use patterns to help us figure things out. So we're going to use patterns right now to kind of figure out what to do about zero exponents and negative exponents. So somewhere off to the middle of your paper, because I'm going to be going to the left here. So just write 10 to the first, 10 to the second, 10 to the third. Okay, leave yourself a little space here. What's that? Oh, scoot it up. Yeah. There you go. Okay, so we've learned that 10 to the first power means just a 10. Not times itself, it means you got 110, right? 10 to the second means 10 times 10, which is 100. And 10 to the third is 10 times 10 times 10, which is another 0 added on, okay? So, the deal with when your base is 10, your exponent is like a big flashing neon sign that says, hey, you better put this many zeros. So if a 10 is squared, it means put a 1 and include 2 zeros after it. If it's cubed, it means put a 1 and include 3 zeros, right? So it doesn't mean write 10 with 3 zeros, okay? Because a 10 with 3 zeros is actually one more than you would want. So it's a 1. So this 1 tells you to put a 1 with 1 0, right? Okay? So keeping that in mind, let's look at this pattern. So to get from 1,000 to 100, didn't I just divide by 10? To get from 100 to 10, I just divided by 10, right? So for every exponent that this goes down, 3, 2, 1, what's next? 10 to the 0 power. And do what the directions say to do. Okay? Except that doesn't work for this one here. So this is a 1 with 3 zeros, with 2 zeros, with 1 0. And so what would 10 divided by 10 be? 1. Which is true, right? Because it says, how many zeros do they want me to put? 0. A 1 with 0 zeros is 1. Joey? Just for base 10s. Yes. So 10 is a special number. You know that, right? You've learned it since base 10 blocks. 10 is how we learn things. So this just works for the 10s here. So if I keep dividing by 10, and basically what it does is it takes off another 0. And that means that 10 to the 0 power is 1. You know what else it means? It means that anything to the 0 power is 1. Meaning 5 to the 0 power, 1. 42 to the 0 power, 1. X to the 0 power, 1. Okay? It's like the weirdest thing to think about, but it's so easy, right? Any base that has an exponent of 0, the whole darn thing turns into 1. Not just the exponent turns into 1, not just the base turns into 1. Everything it's like poof, it's gone. Okay?
I was going to ask, with x to the 0 power, wouldn't it be 1x?
Nope, it would just be 1. Everything completely disappears. So I'm glad you asked that. Okay? So everybody got that? X to the 0 power, anything. When you see a 0 exponent, look at its base, make everything 1. Okay? This is a little trickier though. What if I had 5x to the 0 power? Do you remember what I said about how the coefficient is kind of like all by itself and it separates? It's not got any ties to that x, right? That 0 has nothing to do with that 5, does it? So what do you think that is? This answer is really what? 5, right? Because 5 times x to the 0 means the same as 5 times 1, which is 5. Not adding, it's multiplying, okay? Do you see what I mean? So like negative 4, x to the 0, y to the 5th would be what? Just negative 4, y to the 5th. So here's what's kind of cool about x to the 0 power. X to the 0 power means it turns into a 1, and 1 is the identity element, right? Identity element meaning that whatever you multiply 1 by, it stays itself, right? So a lot of kids, when they see an x to the 0 power, they kind of just will go, whoosh. I know that just means times 1. Okay, and what is all this times 1? It, right? Itself. So it's kind of like, just pretend like it's kind of gone, but keep that in mind. Okay, well, I want to show you something you're going to be like, oh, I understand why. Remember when I had a to the 5th divided by a to the 5th? What did you make that? 1, right? Because remember how I always say bring the smaller to the larger? Well, what if they're the same? It doesn't matter where you bring them, because 5 minus 5 is 0, and what's a to the 0 power? Oh, do you see why that is? So that's why when we learned division in Learning Target 2, I said to go ahead and cancel them, turned into 1. That's why, because when you subtract their exponents, it's 0. And that's all there is with the 0 exponents. We're going to get into negatives in a minute, but if you want to, right here, real big somewhere, any base raised to the 0 power will always equal 1. Okay? Pretty easy. You see a 0 power, make it 1. Don't make the exponent 1, make the whole thing 1. Okay? And that's all there is to that part of the notes. Let's get to the negatives now. All right. Let's keep our pattern going. And let's take, got it all written? Let me go back up. So, if I keep going with 10, 3, 2, 1, think of a number line. 0, what comes next? Negative 1. 10 to the negative 2. 10 to the negative 3. And so, below it, and this is where bell work comes in handy, right? We did negative exponents on bell work for quite a few months, right? So, if the exponent tells you how many zeros to put, you can't have less than 0 zeros, right? You can't have a negative zeros. So, what we're going to do is just keep going with this pattern. Take the previous one and divide it by 10 again. That's a division symbol. My screen doesn't look very, that's a division. So take that 1 and divide it by 10, and what do you get? 1/10, right? Take that 1/10 and divide it by 10, and you get 1/100th, and then 1/1000th, okay? So, on our bell work, months ago, when we saw something like that, do you understand why now that it kind of flips like that to a fraction? It becomes over 1, all right? So, let's do a couple problems with that. Okay, everybody have that all written? So, one of the first negative exponent problems you saw looked something like this. I don't want to do that one yet. 5 to the negative 3rd power. I think this was like September bell work, week 1 or something. So we'll ignore this one. We'll come to it. So that was 5 to the negative 3rd power. And remember what I said, that you, first of all, you can never have negative exponents. Ever, ever, ever in your answer. Like when you work on your independent practice, it's going to say your answer should contain only positive exponents. So the first thing you need to know is get rid of them. Can't be there. And do you remember me telling you that the base and the exponent are buds for life, right? You can never separate a base and its exponent. They're like super glued together. So if I'm going to move that negative 3, I have to move the 5 with it. And what else do you remember me saying? Hello. Yes. Okay, go ahead. And remember me saying about if you move the base, the exponent, the base has to go with it. And if you leave nothing in the numerator, then you better put a 1. Some of you forgot to do that last test. So this changes the exponent to positive, but nothing else. The base is kind of, it stays. It doesn't change that. Okay? Yes?
Why does it change neutral or positive?
Because of this reason that we did with this here. So it's almost like I'm kind of working my way around this chart right here. So if it's negative here, it's positive here. See how the negative, like I want you to look at these two symmetrical ones. So the negative one is over 10, but the positive one is 10 over 1. So they're basically reciprocal answers of each other like that. Okay? Okay, so now this brings up a couple questions. What if that 5 was negative? Oh, and by the way, this answer would be 1 over 5 cubed, which is 1 over 125, right? Sometimes they'll ask you to simplify it all out down to no exponents. Then you have to do that, or you could leave it like that. So what if your base was negative also? They want you to take negative 5 to the negative third power. Okay? The most important thing to know is that it's still the same process, except the bases never changed. I didn't change that 5 to a negative when I moved it, did it? Did I? So what do you think is going to happen with that negative 5? It's going to stay. So watch what this answer is. Okay? Do you see why? Because only the exponent changes. Okay? So that's first thing to keep in mind. So you're going to move that like that. Okay? So are we ready to talk about, so that's with just negative exponents by itself. Now let's talk about with multiplication. Because I'm going to separate your homework by 3 sections. What they look like in multiplication problems, what they look like in division problems, and that's the only 2 we're going to get to today. Because I got to save tomorrow for power of a power. Okay? Okay. So here's what it looks like with multiplication. It's going to look like, I got to do one more thing. Yeah. Let's take this. 5x to the negative third power. So let's do this before we get to multiplication. Okay. So 5x to the negative third power. Remember what I said. The exponent has one base. The base is not 5. This time, 5 is a coefficient. Up here, it was the base, right? So, remember there are no ties right there? So, what needs to move and what something actually stays? So, the 5 this time is going to stay, and the x to the third moves. Do you understand why? Because the 5 has its own exponent, and it's 1, and 1 is positive, and positive exponents do not move. Okay, I really need you to see that. Okay, so if you have negative 4a to the third, b to the negative 6th, and my question to you is rewrite that expression or that term with only positive exponents. You would say the 4 can stay, the negative 4 can stay, the a to the third can stay, but the b to the negative 6 has to go, and it turns into positive 6. Okay? So I'm going to kind of write this out because I got one more to show you here. So if I have a to the third, b to the negative 6th, divided by c to the negative 5th, and d to the 8th. If it's got a negative exponent, it's got to move. That has to get here. This has to go up here. And those 2 are okay to stay, right? So what would this look like? This would look like an a to the third staying put, and a c to the now positive 5th coming to join it, right? Then it would look like the b to the 6th and a d to the 8th. Is that what you were thinking it would look like? Okay, pretty easy? Okay. So that first part was just kind of moving things around. All right, now let's talk about what it's going to look like with multiplication. All right. So if I were to ask you to multiply negative 5x to the 5th times 2x to the negative third power. Okay. You kind of have a decision to make because at first you're thinking, oh my gosh, Mrs. Z said if there's a negative exponent, I got to move it. I got to move it. I got to move it. And everybody thinks that moving first is the right way to go. And it's actually not, because sometimes you're going to be creating more work for yourself. So you may think, oh, I got to move that -3 all the way down. No, you don't. Because this takes us back to learning target 1. Learning target 1 said multiply the coefficients and do what with the exponents? Add them. So let's multiply -5 times -2, and let's add 5 plus -3. And that's what? It's 2. Is it negative anymore? No. So I don't need to move anything. Okay? So I'm going to ask you to do kind of like what I did for these problems. Didn't I ask you to do it first, then? So let's do the problem first, then see if you need to fix anything. Okay? Because this could also end up happening. What if I have -5x to the, this time it's negative, times the 2x and the 3 is positive? How would that change your answer?
It would be a -2 still.
This time your exponent would be a -2, and then I have to go and do what? So I can't have negative exponents in my answers, so I really have to turn this into, does the 10 need to move though? No, because it's not the base. The -10 will stay, and that will move. Got it? Okay. What if I have something like this? 5a to the 3rd, m to the 0, times -a to the -2nd, m to the 4th. Okay, if you can get this, then I know you're with me. Okay, let's treat everything separately. What is the coefficient in front of that a? Because the a is not negative. The one in front of it is. And let's do 5 times -1 first, which is what? -5. Then let's do the a's. I have, and just to make it fun, let's change that -2 to a -12. Everybody add a little 1 in there. Make that -2 a -12. So 5 times -1 is -5. 3 plus -12 is what? -9. And what's this thing? The whole thing is 1. And in this case, watch. It doesn't really throw you off very much here, because what's 0 plus 4? 4, which means m to the 4th. But I'm not done, because my answers cannot have negative exponents in them. I need to completely rewrite this as what? What's the only thing that needs to move? That. Everything else is okay. So your answer is -5 m to the 4th over a to the +9th. Did you follow me with that, Cheyenne?
Like when you were doing the m to the 0 power, like when you changed it to 1, why wouldn't it be m to the 5th? You changed it to 1.
I didn't change the exponent to 1. I changed the whole thing to 1, meaning the m is no longer there. Did everybody hear a question? She wanted to know why this wasn't to the 5th power, because she wanted to take that 4 plus that 1. But it's not m to the 1st power. The m is gone. That just means 1. So that basically means 5a to the 3rd times 1, which means it's just that. So the exponent doesn't change. The whole thing changes. Okay? So everybody's follow me on that problem right there? Okay, because we're going to move on to division then next. Are you with me? All right, so let's move on to what this looks like for your division problems, okay? And here's the thing, the rules are all the same. Nothing's changing, except you just got to deal with the same part of it, just with negatives now, okay? So if I had, a to the 5th divided by a to the 7th, you know that this comes down here. I know they're not negative right now. But you know that this was the 1 over a squared, right? You knew that. Or, if it was flipped around, then your answer was just that, right? Okay, so nothing new. And I don't know how many times you guys told me, take the smaller to the larger, take the smaller exponent to the larger, right? Take this 5 down here, take it up here. Okay, let's keep that in mind and do this. A to the negative third divided by a to the 8th. Okay. So, as I look at this, you have two options. One is the safer but longer option, and the other is the shorter, but you have to kind of remember one little trick in your head, and some people forget that one little trick, so then they should probably go the other route. Mrs. E said get it positive, get it positive, get it positive, so I'm just going to take this whole darn thing down here, move it, just like we did a little bit ago, and now make it positive, which is going to leave me with 1 over a to the 8th and an a to the 3rd. That's now positive, right? That's an option. And now that you got it positive, you keep the base, add the exponents. That's 11, right? Just from looking at that problem, you might have thought a 5 was going to pop up somewhere, right? Okay, because you know you're subtracting. But watch. This step is not really necessary, because if you just go with what I've been telling you the whole time and take the smaller to the larger and subtract, you don't have to show that. However, look what happens when I bring the smaller to the larger. I am subtracting a what? Negative 3. And because I'm subtracting a negative, I'm really adding 3 to that 8, correct? And if you are not a person who pays close attention to detail or who rushes through, this might be a safer bet for you, because you're going to look at that and put a 5, right? And it would be a 5 if that 3 wasn't negative. But you're subtracting a negative, which means you're really adding. Are you with me? So how about this one? How about x to the 5th divided by x to the negative 11th. Take the smaller exponent to the larger and subtract it. So take that negative 11 up here and subtract it, which really means add it. And I'm not opposed to you doing that. So you putting a plus sign right there. Okay? So this answer is actually going to be, excuse me, x to the 16th, right? Not 6th. So be very careful with that. Okay? It gets a little more confusing when they're both negative. X to the negative 20th divided by x to the negative 40th. Let's not do, let's say 41st, just to make it. So, you're looking at that thinking, you know, you have a couple options. You know what some people would do? They would switch them and get them both positive. And then bring the smaller to the larger. That's a wasted step. Which one's smaller? You have to be able to recognize that first. Which one's farther from 0? This. So what am I going to do? I'm going to take this up, and now is the time where it might be a little helpful, because now that 20 is negative, I really am going to what this time? Subtract. So this is going to give me x to the what? I know it's always as it went off. That's 41. So count up from 20 to 41, and that's what? Is it 21 or 19? What's the difference between 20 and 41? 21. Some people are mouthing, looking at, why is it that? Okay, let's do it. It's a little less trickier numbers. What if I had x to the negative 4th divided by x to the negative 9th? So this is going to come up here and get added, right? So this is actually x to the 5th. How about this one? A to the negative 7th divided by a to the negative 3rd. Okay, go ahead and try that one on your own. Okay, what you got? Do you have 1 over? And then this 7 comes down and gets added because that negative 7 was subtracted 1 over a to the 4th. Do you have that? Yep. Okay. So now let's add a coefficient and we are done. So what happens now with the coefficient? Nothing different than it was before. So if I had, for example, 15 x to the 3rd y squared, or y to the negative 2, over negative 3 x to the negative 4th y. Let's keep it that. Just do them like 3 separate problems if you have to. What is 15 divided by negative 3? It's negative 5, right? Then which one's going where? Negative 2 is smaller than positive 1, and negative 4 is smaller than 3. So we're going to have a fraction, right? This negative 4 is going to be brought up and subtracted, but when you subtract a negative, it's really the same as 3 plus 5, which is 8. And what's that? Oh, gosh, why was I thinking of 8? I was thinking of 15. Thank you. What did I say? Oh, okay. Oh, you know what? Because I was thinking of that. Okay, either way. So then bring this down, and you have 1 plus what? 2. And so that's going to give you what? Y to the 3rd. I don't need to have the 1 there if there's something else there, right? Okay, so you got that? All right, I'm going to give you one to try on your own. Are you ready? 6a to the negative 3rd b squared divided by 8. A to the negative 5th b to the negative 6th, we'll say. All right, try that whole thing. You know, right off the bat, it's going to be a fraction, right? Because of 6/8. That reduces to what? If you have to do the circle and the arrow thing, totally works for me. All right, now be careful with this. Here, I'm going to have a to the negative 3 plus 5. And here I'm going to have b to the positive 2 plus 6, right? And they're both going up. So this is going to be a to the 2nd, b to the 8th. Got it? Yay? Okay. All right, so you are going to have your practice sheet. I will be seeing you guys all this week. You guys I'm stepping first, second, and third hour, so I'm not going to see my first or second hour all week. Really see. So I told them that I'm continuing on with notes, and they're just going to have to watch them on YouTube or something. So you guys are going to be lucky that you're not missing days with me. Yeah. So first, second, third hour. Is this going to be for homework? So yes, I will be checking this from you guys for homework. And you're told to bring your own earbuds, right? If you want to. Everybody know where they're going? Anybody in band and choir confused on where to go? Oh, I don't know where to go. Okay, let me show you the list. That's a good question. You guys go straight there. I think that you report to your testing session. So you don't have to go check in with anybody. Let me show you. So, here's how this works. If you're in band and your middle name is between A-L and H-O, then you go to What's that? Oh, did I say middle?
Yeah.
You know what I was thinking? Because I was thinking middle, in between. If your last name is in between these two and you're in band, you're going to room 125 to Krupe. Okay? S-I to W-O from band goes to Debrano's. Actually, he's the teacher, but he's going to be in 148. So these are the choir people. So I want you to take a minute, do some problem solving, do some third grade alphabetizing glossary dictionary word searches, and see if you can figure out where you go. Does anybody need help on figuring out where to go? Don't be, yes.
120 is Miss Everything.
But 120 is Miss Everingham, yes. Yes. So anybody coming in here? I don't think I have anybody in here. Okay. Okay. You know where you're going? And then 7th graders, this doesn't affect you. Because it'll affect I have to figure out every year it really screws up with my other 7th graders. Because I have 7th graders in my first and second hour. So they're going to come to second hour ready to learn math.
And nobody's going to be there.
Yeah, but we're going to be testing. So it's like I got to find something to do with them. Okay, so you guys are good. Okay, go ahead and get that done. You got a couple minutes to at least do a couple of each. And then those of you who are working on tasks maybe can take the last 8 minutes and try to finish those. Yeah. Yes. Yep. And then I sent you the answer keys. Did you guys get it earlier? Yeah. Okay. Mm-hmm.
Is it
It's. I'm glad you said that. It's only 1 through 20. Okay. Did everybody see that? There's 10 multiplication ones and 10 division ones. So look what happens when you get to number 21. Power of a power. I didn't talk about that yet today. That is the big one. So we're going to do that tomorrow. So go ahead and just go 1 through 20. Thank you for asking, Josh. Yeah, there's a couple twists with it.